4 persons. Okay. This is a night. We have only one light. And they have to cross the river, okay, in a minimal time. So you use 1 minute. This 1, 2, 5, 10. Okay. Come here. You. Me. You. So, if we have 2 guys, she's very quick and very slow. If we have to go together, okay, we are going with the speed of the slow ones. It's okay?
Yeah.
Okay, thank you, Mrs. Fast. So, only 2 persons max on the bridge. It's okay? You got it? So, show me the solution. In how many minutes they will be all together here? It's okay? So let's start. In fact, you have 2 minutes to do it. It's okay? 127. You have to go back. There is only one line. This is a 9. Okay. So it's okay? Remember, you have only one light, huh? So you have to come back to the light. Okay? Yes, only one torch. So you have to come back with a torch. Find it. So this is a nice example of collective optimization versus individual optimization. Okay? This one is best. So why? If you take a normal solution like this, need everybody find this, okay, for the first time, it's okay. So you got what? 2, 1, 5, 1, 10. It's okay?
Yeah.
But it's wrong. Okay. So the nice idea, yeah, you got it, was to do this. Okay? So if you do this as a first step, it's wrong. Okay? So to do this, you have someone here. To have someone here, you need someone here. Okay? So for example, I can do this and back B. So at the end of the process, here, I keep -5. Okay? In fact, the 10 absorbs 5. This is a smart idea if you want. So now, I have to do the same thing. Now, remember, you have to go back with another one, which is A, and A is B. So, we have 2, 2, 1, 2. Okay? It's okay for everybody? So, the nice idea is, if you want to go fast, think the slow one. Because the problem was to be all together here. So now, a little bit strategy to understand the position. So, for the first, I compute the OQs. So, first solution, I have here 1, 2, 3, 4, 5. Okay? I use 5 times A. 1, 1, and 1. It's okay? So, second solution. You see? 1, 2, 3. B, you see? 1, 2, 3. 1, 1. So the idea was the following. Too much use of this. So I give to the other 2. I get the same idea. But now I have this instead of this. It's okay? So sometimes we find a solution without a strategy. But the strategy was to get all together on the other side. Why I give you only 2 minutes? You know why? Okay, this is a question. They never speak. It's a code. At Saint George, you never speak. Oh, okay. So if you never speak, you can write. Yeah, you can write the solution. Why I give you 2 minutes? Come on. You don't know. Okay, you know what is it? A hotline at the phone for the computer, you know? you have to solve problems, many problems. So, you have a problem. There is a guy, the first one, can solve the problem. The other one, it's okay. But if this one used more than 2 minutes, it's better to do this. You see? For example, I have a problem with my computer. And I ask you, can you solve it? Or you say, yes, yes, of course, in 12 years. Oh, we say it's not the solution, okay? You see the difference? So, to be better, you need only to be good. So, don't try to be better than someone. Just be good. So, the real solution for a problem like this is I need few minutes. If I need many years to solve it, it's not a solution. It's okay now? So, in fact, in this problem, we give 2 minutes because you have to solve it in less than this one, which is obvious. So, this is an individual optimization because we use the fastest all the time. Okay? But here, we try to have a collective solution. You see? So, the group, because we are going to do mathematics but also strategy, okay, together. So the group is best on the only one. So why? This is in fact, in the best way, a collection. So you have to find how to use the collection with an operation. So, do you want something more difficult now? It's okay? You're ready? Yes, you're ready. Okay. So, I will give you fewer words, but it will be more difficult. They of course can solve it, it's okay. So don't ask them, because they know the solution. So I have only 2 dots, you see, A and B, 2 points. You have only 1 compass. Okay, 1. No cheating. It's only mathematics. Okay? So, only with this instrument, as an instrument, you have to find the center. It's okay? Just this. Now you will see that you need strategy. So let's start. I don't give you only 2 minutes, it's okay. Don't draw the line, there is no line. You remember? There is no ruler, so there is no line. This is a problem. So
I need the compass.
if you have a compass and this, it's very easy. Okay? No? It's easy for everybody, no? Yes? No?
Yes.
Okay. Okay. Your communication is very simple. So, yes. No. Okay, I got it. So, do you understand what I mean?
Yes.
Yes. Okay, great. So, this is the target. So, when you have a problem and you have a target, everybody thinks that you should get the target. Yes? But it's wrong. you have to find the obstruction, the problem. Okay? So the obstruction, obstacles, if you prefer, is, for example, I'm here, I want to go there, and there are problems here. You see the problem? So, I have to do 7. Can I get it? The trajectory has the characteristic of the obstruction, not of the target. So think, first of all, the problems, and after the target. If you solve the problems, we have the target. Even for you, Katya, it's a very good point. So, you have to think now. And if you ask me if the solution exists, it exists.
May I ask a silly question? Can we eliminate the problems?
No. No. You have to do.
That would be great.
No. Would not.
But we're not allowed to use a ruler, just a compass. There.
Yes.
God, can't I use freehand and go there? I'm being cheeky.
Oh, nice try. Yes, there is no ruler. Do you have a compass here? I get frustrated when I come to a question. Okay.
I like to.
So now you find the problem. There is no ruler.
No ruler.
Yeah.
I need a pencil.
So you will see that your mind is going to do the same thing. You will start to do the same thing as if you have a ruler, but at the end your mind will say, okay, it's wrong. So you will see that everybody starts with the same idea, and after that, your mind recalls to you that there is no ruler. So the idea is the following. It is easy to divide the distance. Okay, question. Is it easy to do this? This is an obstruction. Is it easy? Yes, in mathematical terms. Seems to be, okay? But now you have only compass. So it's hard. So in fact, you have to find something which is easy to do what is hard. You see? Don't use this. Okay? Don't use this. This is a waste of time in mathematics. So, I write something. Okay? It's wrong. I do this. It's more efficient. Huh? If you want to be perfect in math, you have to make mistakes. If you want to remove your mistakes, we will have problems. So use only a pencil, not this one. And don't imagine that you have already the solution when you want to find the solution. So normally right now your brain has a problem. So the idea is the following for the resolution. I will give you the solution. So the idea. So you have a problem. You are smart. You think you have the solution. Okay? But you don't have the solution. So you think that you are not smart. So you have a problem. This is the first. Okay? So, at the first glance you say, oh okay, more or less it's the same thing, it's okay? So I will solve it, right now. You are here, because you think you are smart. After that, you don't find the solution. So now you think you are not smart.
It's not feeling bad, that's right.
So, as you have no solution, you are not smart, so you have a problem.
Absolutely. Why am I here?
I just try to explain to you that the problem was already here. So you don't need to do all these things to have the problem. Okay? You have the problem. So it's here the problem. It's not here. Okay. So now I put you a question. Okay? If you don't try to find the solution of my question, you remove my question, and you still have a problem. But I told you that the question was part of the solution, but you don't get it. So you say, okay, it's a question. Like, what is the weather today? Okay, you say, okay, there is no relation with the problem. But there is a relation with the problem. For example, now I don't try to solve the problem, I try to solve the question. So your brain, you know, you have a brain. Okay. The brain has to put a question in his mind. If you find the right question, you will find the solution. If you have no question, no solution. So here, you thought that there is no problem to find the solution. you know there is a problem. So the question was, it is easy or difficult to do this in this context. So now the answer is what? No, it's difficult. It's a good point. Okay? So, second question. Okay, this one is difficult. This one, you sure? With the complex? With the compass? It's easy?
Yeah, because you can put the points on the dot and then you can open it. Yeah, on the dot, and then I just
Put it on A, open it up to B, put it on B, then you do it, there's your double the distance. Oh, sorry.
Because you know, if you say something which is wrong, I would have to say it after. No?
You can, no?
Oh, I know I can. I will do it. You will see. So, imagine your problem. The problem is the following. Okay, you say it's easy, so you do this. Okay, for example, how you know that it's a straight line? You don't have this. With the eye? No. Tomate indiano. No. With the eye you cannot do this. But in fact, you are correct. It's easy. So now it seems to be a joke, okay? Because you say it's easy. She explains you why it is easy, and I said no. And I said that's correct. It's easy. It's okay now? In math, if you want to be good, you have to laugh. Okay. More or less is a good thing. So, in fact, for example, I want to be, this is the distance, and I want the double. Okay? So you will see that it's very easy if you think all the circles as a whole. So, in fact, you use it 3 times. You will use this distance, okay, your compass, you do this, touch, another one, touch, another one, touch. 3 times. Okay? Why this is correct? Oh, come on. It's only the first part. So it's okay? So it was really easy. Yes? You understood? No? Yes? You use the radius.
Yes.
See? You do this. Check. 1 time. 2, 3. So we'll be on the opposite. Here, you have triangles, okay? So, this is the same. So if you do it 3 times, here, you have 5. So, you are in straight line. It's okay now? Okay, so, easy. We've done it.
Now it is.
But this one's still difficult. So, can I use it, the easy one, to do the other? The answer is yes. So let's try it. Alright? You don't smile, you don't laugh. It's a bad thing for mathematics. Because in math, you have to laugh with yourself, with your brain. Or say, oh my God, I never thought that. Can you do, yes, it's possible? She want to be inside? No? You don't smile. No. Everybody understood the easy way. It's okay? So let's draw it. So I say that A, B. So I do this. This is okay, okay? I do 3 times the radius. And I have it here. It's okay? Okay. So, for example, this is the point C. Okay? I can do the same thing on the other side. Okay? Now, I have the double. See? So, I'm here. This is the distance. This is 2 times the distance. Okay? Now I will use a circle with a radius 2D, not 1. So, this is a point. So from this point, try to draw a circle with a radius 2D from this. What do you have? You will be outside, no? There will be tangent here. Okay? So, now try to use this. But for example, you do the same thing with this guy. Okay? This is 1D, 1D. Okay. So, we will try to find something which is rather strange. To cut something in 2 pieces, you have to multiply this and to change your mind. So now you have these 2 guys, and now you want to draw the circle with the 2D. Here we go there, okay? And after what? Something like this, it's okay? So now imagine that they use this point and this one. D, right, it's okay? Now imagine that you take the radius AD, this one. Okay? Okay? With this one, this is the same with this one. No? We agree? Yes, we agree. Okay, fine. So now, you do the circle, and you do this. Okay? You do the same thing here. Okay, so let's do it. So you have to free your mind to get a solution. So the idea was in fact rather strange at the first glance. You see, we were here. We do this. And after that, we do this for the computation. So, for example, imagine that I show you a way. I want to do this, but in fact I do this. And after that, I do this. So, to find the solution, I want to do only one step. Okay? Solution. One step. I go back 2 steps. I drew the radius, and now I have this idea. 1, 2, 3. With this one, I will be at the center of these 2 guys, but in fact, at what distance I am from here? You see? So, if it's easy to multiply and difficult to divide, you have to multiply a lot to divide less to get the solution. It's rather strange at the first glance, but it's okay. So, everybody is okay now? So you can do it, of course, with a ruler if you want at the end to see that it's the same point. So we can prove it, but never mind, it was the idea. The idea was the following. Don't try to find directly the solution. Try to find some points which are going to help you to find a solution. Not exactly the same. Okay? So, for example, can you solve a problem in 4 dimensions? It was only a question.
Is the 4th dimension time?
No, not with time, with 4 dimensions in space. Space. Okay? So, 4 dimensions in space. In maths, we have no problem. Okay? So, you know the word vertex, you know the word edge, you know the word face. Okay? So, you know what is it, hypercube? Yes. In fact, a hypercube is what? Is a cube in 4 dimensions. Sometimes we say tesseract. Okay, don't worry. Now I ask you, how many vertices has a cube in 4 dimensions? Okay? Question. So don't try to be fast, okay? Think that it is a problem. Because you have a problem of representation. But how many vertices? How many edges? So this is a problem, okay? But now we know that is a problem. So we want to find this. So we start with the beginning. Imagine you have only 1 point, okay? 1. Now, you do this. So you will have this. This is a line. It's okay? So now I will do this. Okay? So, I will have a square. Okay? Now with the 4, I do this. I will get this. It's okay? Okay, so the idea is the following. What do I do when I do this? I have something which is here. I keep it and copy and add. You see the process? So the process is the following. I keep in mind the previous one, I copy it, and I draw the relation. So 1 point, 1 point. So here I have 1 point plus 1 point. Okay. It's okay. So in fact I have 2 vertices. You see? It's easy, it's easy. Now, from here to here, it's the same thing. I keep this and I copy this. So I keep, copy. Okay? So in fact I have 2, I will get 4. So now I do the same thing. I keep in mind this, and I copy it. So now you will see that it's very easy to know how many vertices we have with the cube in 4 dimensions. Why? Because only it's a multiplication of the previous one. So here we have 1, here 2, 4, 8. So the solution is yes. So the cube in 4 dimensions has 16 vertices. In fact, it's better to see this. If you see this, you will find that the cube in d dimension will have 2 to d vertices. So now you see the question seems to be very easy. So we solve it. So remember, here is memory, here is a copy, and the global is a process. So if I use my memory, I copy and I find the link, I will get the process which gives me the solution. It's okay? So do the same thing right now with the ages. So don't try to find this, try to find the process. So it's very important in strategy of mathematics. Don't try to find the solution. Try to find the process which conducts to the solution. It's not exactly the same. So this is like an algorithm. Okay? So when we are here, we don't try to do this. No. We try to do this. And you will find this. You see the difference? So in fact your brain uses the same methods. keep in mind something. He copied it, he related, solved it. So, in fact, you have a neural network in your mind, one of the best in the world, but you don't know it. So you say it's only your brain. If it's only your brain, you have a problem. If you think that your brain is a neural network with more than how many, you know, neurons? How many you have? You know? You don't know. Just this. You have all this here. It's incredible, no? So, in the back of your synapse, you have for each one 5,000 up to 10,000 relation between them. So you have a very, very complex computer, but the problem is that many of us are not very good in computation, even with this computer. So if you know your computer, if you know that you have to smile, you have to laugh, to do something which is strange at first glance, you will get a solution. If you don't know it, you say it's impossible. So, you see for the ages now, the problem? So, I remove all this. And I try to do the same thing. So now I want to compute the edges. I have only 1 point, it's okay, it's easy. I have 1 point in my memory, I copied it, it's okay, and I have 1 relation. So this is the first time, plus 1. Now, I have to copy this structure 2 times, okay? But I have to recall that I have to link the vertices with themselves, in fact, okay, because it is a copy. So, here and here, I have another process. So the process here is more complex. I need my memory from the vertices. So this is my memory, this is my copy, okay? And I have to remember how many I put. Okay, so you see now, 1, okay? It's a copy. Plus, what? Plus 2. And we get 4. Okay? But this 2 is quite different from this one. As a process, of course, not as a number. So now, I have this. I copied it. So, how many pages I have here? I will do 2 times, okay? And I will have the relation. So in fact, it's related with the previous number, the vertices. So, if I want to find this, I will say that I have to know the previous one. Okay? So, example, ages. Here, I know this number. And I want to know this number. Okay? So this number is 2 times the previous one. No? Plus what?
4.
Yeah, 4. What is 4? The vertices, yes, of which one? Of the previous one. It's okay? So in fact, it's you got it? It's okay now? No? Oh, I thought, okay. Never mind. So, now we are in 4 dimensions. So, how many ages we have? In 4 dimensions. So, remember, I will use the cube as a whole, okay? So, cube. How many ages here? In a cube, in 3 dimensions. 12, of course. So I will do this 2 times. Okay? Plus what? So here I need the vertices. Okay? So I can write this, but in fact you remember this is 3. So now you have the solution, no? Which is? So, if we remember only this and as a computation, you see, you will get this one, plus this one, plus this one. You do a mistake here, put 20, which is easy, and you say, okay, it's 32. Okay? So it seems to be a power. But it's not exactly a power. Here is a power. There's no power here. So, now imagine you forget all this and I give you only the solution. You remember here the solution was 12. Here, 4. And before was 1. Okay? So you see the number? 1, 4, 12, 32. The question is, do we have only powers? Okay, so let's imagine the following, the next one. So we have this one plus this one plus what? So okay, so this is what? In any case, even if you don't know You see, this is a power, this is a power, this is a power. It's not obvious that it is a power. So the answer is what? In fact, it's logical. If you get a power before in the process, as the process is a sum, we will not get another, except if it was a multiplication, you see, 2 times the power. Okay. But now, this one, I will draw this like this, is not the same. This one is the same, so in fact it's 2 times something. Plus, this plus is not a multiplication. Okay? So, now we have a problem of representation. We are going to use your topology to represent this. So, this is a cube. Okay? Now I want to show you that this is also a cube. Do you see that it's a cube? Yes, you're sure?
Yeah.
Is it a cube? Okay, we are in math test. From her. Test. The question is the following. Is it a cube? The answer is yes or no. So, if you make a mistake, you are dead. It's okay? It's simple. Only one question. So, now you're sure? I give you the same question. You should give you the same answer, no? Before you say, oh yes, I'm sure. So, why it is the same? This one was in geometry. This one is topology. If you say in geometry that this one is a cube, it's wrong. No? Tell her. Yes, of course it's wrong. But in topology, it's correct. So, the idea is, how can we use topology to compute problems in geometry? So it's a very nice idea, very general in mathematics. You have a problem in a field, change the field, find a solution. Okay? So you have a problem in this field. Make a transportation to get the solution in another field. If you can do this, you will do this. You see? So, to do this, we have to find a function. And this function has to have some properties. So, to not disturb the ideas. So, for example, I have a cube. And I want to compute a function to have this. It's okay? So I need what? Here I am in topology, here I am in geometry, and I want to use graph theory. So I would say that this function is good if I keep the same numbers. So here I have some numbers as a graph. I have vertices, I have edges. Okay? So if my function keep this here. It's okay. So in fact, rejection. But that is not a rejection as a whole, because I have some problem, some difference. So the idea is the following. We have here 6 faces. It's okay? You see 6 here? Yes? Because 1 is outside. So this 1, 2, 3, 4, 5, 6. I have to use this. So what I done? I cut here. You see? I take a face, I make a hole, a stretch, and I put outside. So the idea is with this, I can see better than with this. So for example, you know your master eye? What is your master eye? What? Okay. You see the clock? Okay, do this. No, this. This. Okay. You two, everybody. Do it. Straight. Okay. Fix this. The 12, for example. Okay? Okay. Don't you do it like a teacher. Don't this. Okay? So now you close one eye. You close the other. It's okay? So, if you close your master eye, you will not see it. If you close the other one, it's okay. It's okay? So, master eye, right, left, right. Right. Left. You were strange. You said, right. Okay. You, left. What? No, okay, again. Come on. So, for example, we will do the opposite. Okay, I will draw the target. Okay, so you see the target? Of course. So, come on. No, like this. Okay. It's okay. You see the target?
Yes.
Don't do this. No, it's okay. Now I do this. You see the target?
Yes.
You see the target?
No.
Okay, so left master eye. Okay? So, the explanation. So, we have this, okay? You see something. So, if you have your master eye here, you will see with your brain, remember, all the work is done by the brain. The eye is nothing. Okay? No memory, nothing. Input, output, 0. All the work is here. So, you see this. I close the eye, this one. No change. I close this one. Change. There is an angle. So we can do another thing. So now you do this.
Alright.
Okay. And I do this to be sure that it's okay. Fine. So now I do this. And this. And you will see, if I close your master eye, so the left, you will see that the finger is going to move. But you know it's not moving. Why it's going to move? Because your brain sees alpha. So it seems to be more here or more here. Okay? So, now the explanation.
Oh,
The explanation is the following. I am on the board, here. For example, here at the center. Do you prefer to sit here or here? So, with the right master eye, people prefer to be here. With the left, they prefer to be here. If you don't know this, you will not use it. So this is a very big mistake. For example, you are on the plane, okay? You remember the seat, Alpha, Bravo, Charlie, Delta, Echo, Fox, okay? You prefer Alpha or Fox? Try to imagine yourself in the plane. And you will see, imagine the plane is free, of course, not full. So, and you have to sit where you want. So you will see that someone which have the master eye, the right, prefer this. So Fox. The left, Alpha. Okay? So it's very easy, for example, for your foot. Your feet. So right, left hand, right hand. But you have to compute also the eyes. The eyes are more representative of your brain. For example, I want to shoot this target, you see? Okay, so I'm here. For example, my master eye is the left, but my good hand is the right. Okay? So, if I am done, I will do this. If I am smart, I will do this. So it's strange because sometimes we have the same, okay, the same side. So it's okay, it's easy. But if you have the other side, you have to fix the target with the master eye, okay? So if you do this, you will get the target. If you do the other one, you will not get the target, and you will say, oh, I'm not good in this field. You are not good in this field. Okay? Not in this field. In this field. So, if you choose your master eye correctly, you will see something. For example, imagine now, because you have to know your brain to do good things. Okay? So imagine draw this. Draw this. So now we want to use mathematics to know better your brain. If you know better your brain, you will get more mathematics. So now if I ask you to draw the cube, you prefer this one, this one, this one, or this one. So I will put number. Okay? Give me a number. 1. Here, for example. Oh. Okay. 2. 7. And you?
15.
15. It's okay? So, imagine now, you prefer 1, 2, 7 or 15 to draw your first cube. Don't say it, write it. You write only a number, okay? So, we have a number. Now, you remove the choice and you write me the second number, okay? So, for example, for you, imagine, you put me 7, okay? I remove this and I ask you, what do you prefer? Okay, so you're right. After that, I remove the other one. What do you prefer? 1, okay? And at the end. So, this will be your signature. So, how many different people can I have? How many? It's very easy. It's not easy, it's very easy. So you should say directly the solution. How many? First, 4 choice, 3 choice, 2 choice, 1 choice. Factorial. Huh? So we have 24 types of person. Okay? But we don't use it. And it's wrong. Okay? With my pupils and my students and my everything, I always ask this. Because the methodology will be different. So, for example, who prefers this? Okay. So, who prefers this? It's not a wrong, is it? I'm not sure. So, there is the better is to do this. You put it on. No one else. It's your choice. It's okay. Okay. So now I want you to draw your cube, your preferred cube at first. So draw it. This is your preferred one? It's a joke. This one? This one? You don't like to draw? No? You don't like painters? So, for example, this is a square. So you will draw all the process. So here I will put this. For example, for me, you put this for you, okay? So now, I have this and I put the first diagonal. Here, I draw the chair, it's okay? And after that, I close it with this, okay? So, the idea is the following. If I ask you to draw very fast. Okay. I have to put some remarks, okay? So, I will give you the idea. You see what I've done here? You see, or not? I do this, and you see I keep the same thing. Eh? Okay, so for example, if you draw me this, I draw it somewhere. So 0, 0, 0, 0, 0, 0, So, because in fact you draw it, but you don't think that I want this. You simply draw a cube. Okay? So again, I do like you. I do this. I have to do this. I have to do this. After that, I do this. I do this. I do this. I do this. And I get 1 point. So it was very difficult, no? Because in fact, you don't answer to my question. You answer to your question. So, if I want to draw the cube like you, okay, I can do it. But it was not the question. So it was very nice here because there were a lot of work here, just here, and I don't ask this. You are disappointed. Me too. Because I just show you what I want. I just want this. You draw all these things. Okay? So now imagine that I ask you something which is much more difficult. You will see that now you will do what I want. Why? Because it was easy and it was what you already think that you know it. So now I want to draw a dodecahedron. Okay? It's okay, it's easy, no? Yes, no? The specialist? Oh, yes, no? No, okay. Correct. So now, try to find the way to do it. So, first, we draw a pentagon. Come on. So you will see now what is an algorithm and what is a position. So, the biggest one, not a standard. Okay? So now you do this. Just this. You remember, it's the same idea. Okay? So it's the analog of the chair. Okay. Now, I will put a diamond like this. So in fact, you can do this. Do you see the difference? You see the difference? Okay, do this. 1 point. Huh? At the center, at what distance? And you will draw it. So now you will learn, go to the link. It's okay? Now you do the same thing, but behind. So now I would put the pentagon upside down here. So here. Okay? And now I do the clean up things. Okay. So now you will see that if I ask you to draw it here on the board, you would do it like this. Why? Because for the cube, it was easy. For the decagon, it's difficult. So your brain accepts the methodology to do it. Here, say, okay, I don't mind. You see the difference? So, let's do it. Don't make a painting, okay? Just a draw. So I want to show you that if your brain knows that you have to do something difficult, it will accept an advice and it will use it. If it thinks that it's easy, it will remove the advice and it will say, okay, I can do it. So now, for example, don't see. I know you see. At the end, you will see that you've done something which is incredible. And your teacher will be proud. Oh God, it's yours. It's yours. To the next, okay, it's okay, it's okay. Oh my God, what I did. But it was me. Of course, if you draw it, start to think how many vertices you have, how many edges, and how many faces. And I will show you a new idea now, is in mathematics, we love to do computation without computation. Yes. It's only brain computation, but not really computation. For example, you want to see how many faces you have. Of course, it's a dodecahedron, so you know the result. But if you see your draw, you will see that you have a pentagon. The pentagon have 5 edges in contact, and you have another one on the other side. So you have 1, 1, 5, 5, so it's 12. By the way, remember that you've done this with that and without that, and you did it. If you use very much this, you will have problem of methodology. If you think that you have only this, you will get smarter. So remember, only this, huh? Not this. That's not good. Not good. No. So, my specialist. So now, I want you to give another problem. You see, we create this chessboard. You play chess? Who plays chess? Only one? You don't play chess? You? No chess? No chess? Chess? Only one? No, I don't say like Kasparov or Kramnik, okay? I just say play chess. So, you play chess? You know chess? No? Yes? Maybe? You don't know, okay? So, for the teacher, they should play chess. All. Do you play Go? You don't know Go? Veki? Yes. Stones? Yes. You know this? Oh. You play Go?
I don't play it, but I know the game.
We don't have time for games.
How we are going to do game theory?
That's
Yeah, it's a field of mathematics. So you play shogi? Shogi? No?
Oh, yeah.
Oh.
Oh! What? You play shogi? You know shogi?
On Japanese.
Yes, Japanese, yes. Japanese chess.
I know everything.
So you play chess, yes or no? You just do this. Just play the moves, okay? Okay. Go. You play Go? Okay, shogi. Shogi is like chess in Japanese. No? They should play shogi. Okay, so chess. Homework. I will tell you, and also to your parent to do this. Okay, so chess, Go, shogi. They are very strategic game, a lot of math inside, and it will help you your brain. So, this is the chess we created, the chessboard. You see it's 9 by 9. You see it? Some? Yes. So, for example, so I'll ask you something which is simple for the moment. Oh, I don't know. So in this chessboard, I call this, and for you, oh, I have another one. Okay. Don't be jealous. So, you see 9 by 9. There is a hole here. Nothing here. Okay? So, the pounds here, 9 pounds, not 8 like in chess, classical chess. Rook, knight, bishop, 2 queens, and 1 king. It's okay? You know, you remember the move in chess? For example, the king is like this. Okay? So now the queen. The queen is like this. You see the difference? Only one step. How many? Okay. So in fact the queen is a combination of the bishop. Come on, you have to write this. Not on the chessboard. And the rook. It's okay? So remember, it's more like mathematics in fact. This one is equal to this one plus this one. This one is the same but with a border. Okay? So, you have also the knight. Remember the knight is done like this, you know?
Yeah.
But in fact, it's not the correct point of view. In fact, the knight do the simplest move which cannot be done by the queen. You see? Not here, for example, in this one. For example, I am here. I am the queen, here. The first square, which is impossible for me, is here. Correct? Here, here, here. You see? This is the move of the knight. So, they are complementary. Complementary, which means not the queen at first step. So I have not the queen with the border. You see now codification. So I will use the same, and of course I have the pawn. You remember the pawn? So I do this, 1 or 2, here or here, and I will get this only once. You see, if you draw this, even if you do the same in Go or Shogi, you will see that there is a lot of mathematics and we use it. So, for example here, a very simple problem. You are here as a bishop, okay? You see that all the bishops are white. See your chessboard. You see that all the bishops are white? Yes or no? Even if I have black and white, they play on a white square. It's okay? So, there is a problem. So the following idea is quite different. So this one is a chessboard third. So this one is Sierpinski, mathematician. This one is Einstein, and this one is Rosen. Okay? Einstein and Rosen. So we have one mathematician, two physicians. Okay? So this is for the bridge, this is for the structure. The structure is the following. You have 9 by 9 and you remove the center. You do the same thing right now. Remove the center. You see? You know what this is? This is a fractal. So, the structure of the chessboard, sir, is a fractal. Complete, without this, with this, with this, with this. Now, why it is a bridge with Einstein-Rosen? In fact, if you have any one of all these pieces here, for example here, it will do a hyper move. A hyper move, like 4 dimension, is 1, 2, 3. Can go there. You see? So, you have something here, show me where it goes. One, two, three. In fact, here and here. You see? So from here, with a hyper move, you can do this. It's okay now? With all the pieces. So in fact, it's the move of the knight. 1, 2, 3, L, or gamma, if you prefer. So now, imagine I have my bishop here. Okay? For example. And I ask you if I can change color. You see? So I will do this. One move of the bishop. I will go with a hyper move here. And another move, I change color. You see it? So this is a way to play chess with this chessboard, sir. And we have different chess also. We have fortress chess. So I don't ask you to be a professional in chess. It's not the idea. It's only a thing. So in this chess, we have four girls. Sorry. So we play like this. One is here, one is here, another one here, another one here. Okay? So, for example, you have your pieces here, your pawns here, and this fortress belongs to you. And you can go inside by this door. This is forbidden. This one is yours. Okay? So, and for you, it's forbidden here. So we play 2, 2. We have a group, okay? So it's a team work. So you play, for example, she plays, etc., like this. And you are together, they are together. Okay? So here is the same thing, but you have a fortress sir chessboard, okay, with 4 players. So it's very, very nice to do this. Why? Because you can do many computations with the other. You have a team. So in chess we have no team. In chess, in classical chess we have no team. Here we have team, and it's much more longer. So you have to compute many things, and it seems to be like exactly mathematics. We have the teamwork, research, to find something together. It's okay? That's all, folks, for the moment.
Yes, sir.
Thank you, thank you.
Thank you.
That is wonderful.